On how to set up some triggers in S&BOX. If you were watching the last tutorial, you might have been wondering how I was able to set it up so when the player walks in these different colliders, it triggers something. So I'm going to show you how to do that. I'll also show you how to detect bump collisions and colliders. It's really quick and easy, so let's just jump into it. So first, I have this hurt and this heal cube, and both of these are going to be triggers. So on their box collider, I have it set to true for each trigger on both of these guys. And I'm just going to go ahead and add a new component, and I'm going to call it the heal trigger component. Put that in our code folder. It's really quick and easy, so let's just jump into it. So first, I have this hurt and this heal cube, and both of these are going to be triggers. So on their box collider, I have it set to true for each trigger on both of these guys. And I'm just going to go ahead and add a new component, and I'm going to call it the heal trigger on their box collider. I have it. So first, I have this hurt and this heal cube, and both of these are going to be triggers. So on their box collider, I have it set to true for each trigger on both of these guys. And I'm just going to go ahead and add a new component, and I'm going to call it the heal trigger component. Put that in our code folder. And simply all we want to do, let me just make sure I have the solution open. So we just want to make sure our component extends component dot I trigger listener. And you see there's also I collision listener to get bumps instead of entering a trigger. So you'll see if I hit F12 on this, there's an on trigger enter and an on trigger exit. Both of them take a collider. So very simply, all we need to do is public void on trigger enter. And now we've implemented this interface here, and we can just put our code into either one of these, and it should just run properly. So here I can say log.info other, and I'll say log.info other in the exit. And if I run the game, we look at the console at the bottom. I walk inside, it prints the capsule collider that's on our player, and when I leave, it also prints it. So I want to set these up to actually heal the player and then do some damage. So I probably don't need to explain how to do that, but I might as well show it for the sake of the video. Property, public float, maybe just float amount.
Welcome to Fish School Episode 1. In this series, we will be recreating Snot Farm, a FacePants classic and the first game to feature the beloved Citizen, also known as Terry. As a disclaimer, S&BOX is still heavily in development, so things might be replaced or moved around. If you find out that something in the tutorial changed or is missing, make sure to read the pinned comment below or let us know in our Discord server. For the sake of keeping this video short, we'll assume that you already have a code editor installed, although it won't be necessary for the first few episodes. If you don't have one, FacePants supports Visual Studio, Visual Studio Code, and Rider. C# knowledge is not required, as I'll try my best to keep it simple, but preferably you understand the basics. In this episode, we'll explore the tools, the editor, and how to create your first project. When booting up S&BOX on Steam, you'll be given the option to either launch it in play mode or launch the editor. If you don't see it, you can re-enable it here. Let's launch the editor, and this window will appear. On the right, we have your projects, and on the left, we have useful shortcuts. Click the big blue button to create a new project, and give your project a name. Here you can change your project location. I suggest not selecting a different drive from your operating system, or a folder that is synced with Microsoft OneDrive, as those have been known to cause some issues in the long run. Create the project, and now wait for everything to compile. If this is your first ever project, it will take a long time to compile everything. It will freeze and may take up to 10 minutes, but don't worry, every time you open your project in the future, it won't take more than 30 seconds. Here we have the default editor. Although the layout might change in the future, we have the default scene in the center, with tabs to view other scenes and the game currently running. Hold right mouse to look around and WASD to move inside. Shift to speed up and mouse wheel to change the camera speed. The scenes hierarchy, one for the game objects and one for the UI panels. The inspector on the right to edit components or preview assets. You can click on the log to stop it from changing to other selections. The asset browsers, one for cloud assets and one for your local assets. You can look for files, filter, change how they are displayed, and more. Our trusty console, the sounds mixer, library manager, performance, and you can edit your layout however you want. Drag these windows, delete them, add some other windows we won't look into, save your layout, or load back the default one. Let's reopen the default scene. Looking at the assets browser, you can see that a project in S&BOX has a specific layout. We have the assets folder, which is where you'll have your models, sounds, materials, maps, scenes, prefabs, basically everything except code, which goes in the code folder. We won't explain the other folders for this tutorial. And now, we can finally get to the game objects and components. Game objects are the smallest common denominator in S&BOX, containing all information on their name, tags, position, rotation and scale. Components, on the other hand, give them a purpose. Render a model, create a particle, play a sound, move your character. All of these are achieved through components. Let's click on one of these cubes. You can drag these arrows to move them along the axis. Switch to rotate mode, up here on the top right, or scale mode. The keybinds for them are W, E and R. On the inspector, everything about the game object is displayed. Its name, tags, transform, which is the position, rotation and scale. For this cube, we have the model renderer component, currently rendering the default cube model and tinting it magenta. As you can see, it disappears when I disable it. For component editing, you have the classic right-click, collapse, etc. etc. Next up, we have the box collider component, which creates a solid box 50 units wide, 50 units long, and 50 units tall. Then there's the rigid body component, which enables physics simulation on the cube. To show off the results, let's drag up these cubes and remove the rigid body for one of them. When we go to the top to start our scene with the play button, the two cubes with the rigid body component will fall while the other stands still. In fact, if you look at this green plane, it's also a game object with the model renderer displaying the plane model, tinting it green, and only a box collider without the rigid body. This is useful for maps, building rocks, anything that doesn't need to be simulated. Stop the simulation, save the scene with Ctrl S, it's good to save it once in a while. Looking at the other game objects, we have the camera, one of the presets you can create. It contains the camera component and some other components for post-processing. It also has a useful preview, which helps you look at the changes you make. There's a few other game objects we could look at, but we'll show them off when we start making our own levels for the game. This ends the first episode. Let's delete the cubes, because next episode we'll be looking into making our own player. Thank you for watching, and do check out our Discord server in the description, where you can ask for help. Welcome to Fish School Episode 2. In this episode, we'll create our our player controller. S&BOX provides you with a default player controller which handles everything for you, from the walking and swimming to the camera and the animations. To access it, all you have to do is create a new game object in the hierarchy and select the player controller preset. Let's rename our into just player. Let's place it at the center of the map and click play. Look at that, it can run and jump, but not only that, it can also swim and climb as well. We'll look at that in a few minutes. If we look at the game object itself, you can see that it has a few components that came with the preset. The player controller component and a few move mode components for climbing ladders, swimming, and the default one, walking. If you wanted, you could make your own move mode, for example a jetpack mode, but we won't be looking into that for this tutorial. An interesting quirk of the player controller component is that it uses what's called features, which are these little tabs on the top. While it's
Before, when you imported an asset from Box Edit, the collision shape in GameMaker was generated automatically. This often caused issues like invisible walls, especially with animated assets. Box Edit would create a large collision box that covered all possible movement positions even if the object wasn't present in most of them. With the latest GameMaker Update 0.12, you can now override Box Edit collisions and define custom ones directly inside GameMaker. For example, take this group, it's one animated asset. Previously, I couldn't enter the circle because its collision box was massive. Now with the new editor, I can simply set the main asset to non-collisional and add individual boxes around each NPC. After a bit of tweaking, I can achieve a realistic
custom models, open up Model Dock and add a render mesh file. I'll find the folder for my add-on. And I'll create a models folder in there. You can actually save your models anywhere you want, but since I'm going to be making a regular prop, I'm going to save it in the models folder. I'm going to make an industrial prop, so I'll make another folder called props_industrial. I found this industrial box on 3dmodelcc0.com, so I'll download it. It looks like this came with an SBX and all the textures. So I'll drop this electrical box folder inside my props industrial folder, and then open up the SBX. I'll hit compile, and then I'll have to save it. I can save it in the exact same file location with the exact same name as the SBX. Next I need to add a material. So I'll open up the material editor and create a material in the exact same folder with the exact same name. I'll go in and add all the materials. Looks like this one came with base color, metallic, AL, normal, and roughness. Now all these textures are actually 2K, I don't need it that detailed, so I'm going to lower them all down to 512, except for my base color, which I'll only lower to 1024. That looks good. Back to Model Dock. I'll add a default material group. And I'll set it to be the material I just made. Hit compile, and there we go. Now there's no collisions for this yet, so if I'm going to make it a static prop, I can add a physics mesh file. And I can use the exact same mesh as the render mesh. Source 2 actually supports DMX, SMD, SBX, OBJ, and VOX mesh files. That looks pretty good actually. Most of the time you'll want to go in